Hello friends, welcome to the next video tutorial on MATLAB. Today we'll discuss the plot command in MATLAB. So the basic requirement for a plot command is that we require two matrices that will act as the x-axis and the y-axis. So here is the example for a plot between x and y in which x is a matrix between 0 and 10 and will have 11 elements. Corresponding to that, y will also have 11 elements calculated by this relation. Now when I press enter, you can see it will generate a figure like this. So this is the x-axis and this is the y-axis, but this is a very crude demonstration of plot command with no labeling of the axes, no title to the graph, nothing. So for that, MATLAB has various options, like for title you simply write title and in brackets you give the statement whatever you want to display, and this will add the title to the graph like this. So previously there was no title, now there is a title. To label the x and y axes, we use the x label and the y label command, and by simply entering this, you can see now we have x label and y label. Again, there is no grids in this graph. To have grids, we can use the grid command and we can write the grid on command. Now there will be grids. We can turn them off by just writing grid off. So the grids are gone, or we can have the grids, right? So this is another option. Now if we want to plot multiple graphs in a single figure, then we can do something like this. In this, I have defined an x matrix, a y1 matrix which is the sine of x, and a y2 matrix which is the cos of x. So we can write plot x comma y1 and x comma y2. This will plot the two variables y1 and y2 on the same graph with x like this. So you can see that MATLAB has automatically given a red color to the y2 graph and the blue color to the y1 graph, right? We can also control this by giving the line color, line style and marker styles by putting them into the plot command itself. You can see that I have x comma y graph with the red color, R stands for red color, and double dashes for this dashed line, right? And then again x and y graph has been plotted for circles and with blue color, right? Blue color and circles. So these options you can check from here, like here I have given red and two dashes. So here you can check that for red I had written R, and for dashed line there were two dashes. So if you want, these are the different color options that are available. Y stands for yellow, likewise magenta, M, cyan, C are red, and we have different marker styles, like here we had the 0 or round. The other options can be dot, 0, X, S, D, V and likewise. And we have different line styles also. Here we had used the dashed line. We can also use a solid line, a dotted line, a dash and dot line, or no line at all. So these are the various options that you can use for color, marker style and line style. Okay. Now to add legends in the graph, still there are no legends in the graph. To do that, what we can do is we use the command legend. For that the rest of the portion is same. We have x, y1, y2. I have plotted y1 and y2 with different colors. I have given the title, given the x label and the y label. Now I have added the legend fx corresponding to first graph, dy dx corresponding to second graph, and the location of the legend will be northwest. So this is the, it automatically understands that fx corresponds to y1 graph and dy dx of fx corresponds to y2 graph. We have to follow the order in which the plotting of graphs has been done, right? So the different options available with legend are these. Where we want the legend, either above and to the left, then we use northwest. Above top left corner, then north left. Above center of the top edge, then north center. Above top right. So these are the different options that we have for legend location, right? This you can see also by writing help and legend. So see, it has given all the options where you want to have your legend box, right? So this is for legends. Now suppose you have a linear to linear graph that we have already seen. Now if you want a log linear graph, means on x-axis there will be log and log of the value of x, and on y-axis there will be normal scaling. Then for that case we have this graph in which the command is semi log of x. In this case the y will be a normal axis and the x-axis will be a log axis. So here is the graph in which the x-axis is a logarithmic scale, whereas y-axis is the normal scale, right? Again for linear x and logarithmic y, we have the command semi log y. In this case the y-axis will be a logarithmic scale and the x-axis will be a linear scale, right? For a log x means both of the axes will be logarithmic. We have the command log x. Rest remains the same. The rest part will be the same, where you have two variables x and y with the same dimensions, right? Now it will plot the graph, and this is the figure where x and y, both of the axes are logarithmic, right? Now you would have seen that once I plot a new curve, the previous curves just vanish off. So we can use hold command to plot more than one graph on the same axis. So let me demonstrate what I am saying. Suppose I didn't have the hold command here and I gave you this program in which we have y1 and y2, and I have plotted y1, then in the second case I have plotted y2. Let's see what happens. The second curve has only been shown. The first curve did not come, which was corresponding to sin x. Another method could have been, I could have written plot x comma y2 and could have plotted the graph here itself, but in this case I want to write a different plot command. So what I can do is I can give the hold on command and then run this code. Now MATLAB will plot both the graphs on the same figure, and now this is correct, right? So hold command is used to plot more than one curve on the same figure. Okay, now if I want to generate figure numbers for different graphs like this, means figure 1 will plot this, then I want figure 2 and it will plot this, so two figures will be generated. Had I not given this command, only figure 2 would have come. So in this case two graphs have come, right? Figure 1 and figure 2. So this is the use of figure command. If I don't give this and this, then only second plot will be displayed because the first plot is overwritten. Right? To have more than one plots on different plots, we have to use the figure command. We have to give the numbering of the figure 1, figure 2 and figure 3 likewise, right? This was the use of figure option. Now if I want the subplots, I want the different plots on the single figure window, then we use the subplot command. How this is used is like this. We don't have to give the figure number unless and until we want more than one figure. So subplot divides the figure window into a matrix of 2, 1 means 2 rows and 1 column. So these are the 2 rows and this is the first column. So 2 rows, first column and the first figure in it will be this graph. Then subplot 2 rows, 1 column and the second figure is this one, right? For more we can write subplot 2, 2, 1, right? So this will generate a 2 by 2, means 4 windows in a single figure, and will give numbers 1, 2, 3 and 4. First corresponding to 1, 1, second corresponding to 1, 2 and likewise, right? So in this way we can have more than one graphs in a single figure window using subplot command, right? Then we have different options for, like you are seeing that for plotting the graph, the width of the line and the marker edge color, these are fixed. For that we can use commands like this. We can use these keywords: line width, marker size, marker edge, marker face color, and we can define the range or the value of it, right? So suppose I give these commands. Now you can see that the line width has increased. It is much darker graph. It has black color and circles, and marker size is 6, so this circle is more broad. Marker edge color is red, so this will be red. Marker face color is green, so inside this marker it is green. Inside this circle it is green. So these are few more options that you can avail in the graphs. Now suppose I want to plot the stem plots, then we have this command stem x, y, and rest remains the same. Now this will generate the stem graph in which looks something like this, and so we can have stems commands also. We have bar plots, we have pie plots, we have compass plots. So we can have pi of x. This is the pie graph, right? We can have stair plots. So stair, right, stairs x comma y, right? Now this will give stairs for the right. Now you're seeing that there are, this last line is not very visible with this graph. When automatically the axes are generated, you can see that this is not correct. This y-axis starting from 2, whereas this graph would be more clear if we had the axis from 0 to 10, right? So for that we can define axis control V, and this axis is x min, x max, y min, y max. We want the axis between 0 to 10, and x axis between 0 to 10, and y axis also between 0 to 10. So I can press enter, and now the axes have changed. Now the axes are between 0 to 10 and 0 to 10, right? Now suppose if I wanted these all methods were either for a row matrix or for a single column matrix, right? Now if I have a two-dimensional array, then how would I plot? So this example will show you how the two-dimensional plot is plotted. Now you can see that we have defined only x and y, which is equal to length of x, 4 columns, in which the first column has the function as sine, the second has cos, the third is sine square, and the fourth column is cos square, right? Now if I plot this, MATLAB itself knows that it has to plot the 4 columns of y with respect to x, right? So it will automatically plot one column of y with respect to x. So sin x with respect to x, then cos x with respect to x, and you can see that it will generate automatically the colors. So in this way you can plot a multi-dimensional array, then you can plot the various columns of a matrix with respect to some variable x, right? So this is how you control the graphs through command window. Another very easy way of doing this is by simply plotting this graph with no title, no axes, no legends, nothing. Just open this graph, click on this window which says that show plot tools and doc figure, right? So click on this and this window will be opened. Now here you can do various editing, whatever you want to add, right? So you can go to various properties, like suppose you want to edit the axis properties, so you want some limits to be changed, so you can make it from -10 to 10, right? Y-axis you can make it between -5 to 5, right? So in this way, or say -2 to 2, right? So you can see that your axes have changed. If you want grids, you can click on this and you will have grids, right? Suppose I want the grids. Now again you can go to figure properties, go back to figure properties, and you can select this graph or this graph, right? And you can change the lines, all the options that we were changing through text, now we can change here, right? If you want to change the graph, it can also change the graph. If you want a line, you can change the color, You can change the weight, right? Color I think I have changed, so you can see. So again, by clicking on this you can change for this, right? So you can change anything from this figure editor window, right? Finally, once you have completed whatever you wanted to edit, suppose now I want to add X label to the figure, then insert, go to insert, then insert the X label. You can change the text from here also. You can insert Y label, you can insert title, legends, everything that you want to add, you can add through this, right? Once you have completed your editing, go to the files and just click this generate code, and MATLAB will automatically generate the code for whatever editing you had done. Save this file as a program, so you can generate the code of the graph, generate code option in the file option, right? So this is how you can generate an edited curve with all the demarkings on the graph. Thank you for watching. See you soon.